All right, everybody. So today the student will be able to use algebraic properties in order to simplify rational expressions. Well, first it would help to know what is a rational expression. A rational expression is a fraction in which the numerator and or the denominator are polynomials. And a polynomial is really any type of expression. You can have a monomial, which is an expression with one term, a binomial, an expression with two terms, and so on. So a polynomial just means we have expressions on top and bottom of our fractions. So, for example, in example number 1, 3y times y plus 7 is a polynomial. Y plus 7 times y squared minus 9 is also a polynomial. So, if you are asked to simplify polynomials, here's kind of a side note. You don't have to write this down, but if I gave you like 2x plus 7 divided by 2, you might look at this and say that you want to simplify the 2 over 2 because you know 2 over 2 simplifies, but you can't, okay? You can only simplify this if all terms, 2x, 7, and 2, if they're all divisible by the same number, then it can be simplified. So when we were looking at simplifying rational expressions, we can't simplify things when we're adding or subtracting unless everything matches. But what we can do, if let's say, for example, instead of that, it said 2 times 3x plus 4, all divided by 2. Well, because this 2 is being multiplied to everything else, then I can simplify the 2's like I wanted to before. So as long as you keep everything multiplied in groups, then you can simplify things out that are the same, just like you know you can with fractions. So that's kind of a side note if you needed the explanation. So the first thing I'm going to do to simplify is I have to keep everything as multiples. And I do that using factoring. So all day today, you need to factor. Okay? You can simplify things that are factors in the top or the numerator and the bottom or the denominator of your fraction. So let's look at the top. I have 3y times y plus 7. That is as factored as it can get. The bottom, y plus 7 can't be factored anymore, but y squared minus 9 can be, because y squared minus 9 is really y squared plus 0y plus 9, or minus 9, sorry. So I'm looking for two numbers that would multiply to negative 9 and add to 0. So I know 3 and negative 3 will do that. So I can break the y squared minus 9 up into, I still have the y plus 7, but I can make that y plus 3, y minus 3. And on top, I couldn't factor anything, so I still have 3y times y plus 7. Okay, now that everything is as factored as it can be, I can look for factors that are the same. If you have the same factor in the top and bottom, then you can cancel them out because everything's being multiplied. So I can take all the y plus 7 and cancel it with all the y plus 7. But nothing else can factor out. So I still have 3y on top. Or I'm sorry, nothing else can simplify out. And I have a y plus 3 and a y minus 3 in the denominator. You can leave your simplified answer like this, or you can leave your simplified answer, you can take it back to y squared minus 9 because nothing came of it. So either answer is acceptable. When we say to simplify, really the bulk of what we're trying to tell you is get rid of any common factors in the numerator and the denominator. And as long as you do that, it's considered simplified. You can leave your answer in whatever way you feel like. All right, so next it says, under what conditions is the expression undefined? Well, if you think back to just mathematical things you know or have been told at some point in your life, you know that in math, it doesn't make sense. You cannot divide by 0. So when we are asked under what conditions that this rational expression is undefined, we have to take the denominator. So my denominator is y plus 7 times y squared minus 9. And we have to say that anything that makes this 0 cannot be an answer. So we say the whole denominator cannot be equal to 0. So in order to do that, we need to find all its factors. So I already factored. I know that one factor is y plus 7. And I know that y squared minus 9 was y minus 3 and y plus 3. All of that cannot equal to 0. Well, if I made y plus 7 equal to 0, the whole thing would be 0 because we'd be multiplying by 0. So in order to figure this out, we're going to break it apart and we're going to say, okay, well that means that y plus 7 cannot equal 0, y minus 3 cannot equal 0, and y plus 3 cannot equal 0. Because all three of those scenarios would give me a 0 for the denominator, and that can't happen. So y plus 7 can't equal 0. If I want to solve for y, I would minus 7 from both sides. So I would have that y cannot equal negative 7. So I would say that the domain is undefined where y would be equal to negative 7. I have to say that y cannot be equal to 3 and that y cannot be equal to negative 3. So if we solved all those for 0, those are the answers we would get. So if asked about the domain, you would say that this graph, if we put this rational function on a graph, you would say that the domain is all numbers because you don't know anything about anything else, but you assume it's all numbers except for when it's mathematically impossible to be. And this graph would be impossible at y is negative 7, y is 3, and y is negative 3. So your domain is all numbers except for negative 7, 3, and negative 3. And it's weird to talk about domain when our variable is y because domain is always the x. We're just using y here because that's the variable that was originally in our problem. Okay, that was a whole lot on number 1. Number 2, I want to simplify this. So the first thing I'm going to do is I'm going to figure out all the factors. Well, x doesn't break down any further. X plus 5 doesn't break down any further. X plus 5 doesn't. If I made a multiply add chart, I could factor x squared minus 16 into x plus 4 and x minus 4 because I would be looking for two numbers that multiply to negative 16 and add to 0. So that's where I got the minus and plus 4. Okay, now that everything is factored and multiplied together, I can break out common factors. So I can simplify an x plus 5 out of the numerator and the denominator. So my final answer can be left as x over x plus 4 times x minus 4. Or I could leave my simplified answer as x over x squared minus 16. So again, when we talk about simplifying the rational expressions, we're really just talking about what can you get rid of. Your final answer doesn't matter as much. Okay, under what conditions is the expression undefined? We'll go back. We cannot have our denominator, x plus 5 times x squared minus 16, cannot equal to 0. So again, I need to make sure I have all the factors. So x plus 5, x minus 4, x plus 4, cannot equal to 0. So that means x plus 5 cannot equal 0, x minus 4 cannot equal 0, and x plus 4 cannot equal 0. So if I solve these for x, I would minus 5, so x can't equal minus 5. I would add 4, so x can't equal 4. I would subtract 4, so x can't equal negative 4. So my domain is all real numbers, or negative to infinity, except where x is equal to negative 5, 4, negative 4. All right, next example. Simplify and state for what values of p is this rational expression undefined. So the first thing I'm going to do is I'm going to factor both the top and bottom. So if you need some help on factoring, because I'm going to do this really fast, you can always go back to our notes where we originally learned how to factor. But I know that p squared plus 2p minus 3 can be factored into, sorry, I lost my train of thought for a second. X plus 3 and x minus 1. I know that p squared minus 2p minus 15 can factor into x minus 5 and x plus 3. Okay, so to simplify, I'm going to look for things that are the same on the top and the bottom. So x plus 3 can be taken out of both numerator and denominator. So my final simplified answer is x minus 1 over x minus 5. Okay, now I need to talk about the domain because I want to know where is this not, where is it undefined. So go back and I have to use all of the denominator before I take anything out. So x minus 5, x plus 3 cannot equal to 0. And if I solve those both separately, I would say that x cannot be 5 and x cannot be negative 3. So my domain is all real numbers or negative to positive infinity except where x is 5 and negative 3. All right, so same question here. I know that p squared plus 5p plus 6 can factor into p plus 2 times p plus 3. I know that p squared plus 8p plus 15 factors to p plus 5 times p plus 3. I see that there's a p plus 3 in top and bottom. So my simplified rational expression is p plus 2 over p plus 5. Okay, but now I want to know where is it undefined. So I'm talking about the domain. And the domain I have to assume is all real numbers or negative to positive infinity except for where the denominator would be equal to, so it cannot equal 0. So if I solve those separately, I would know that p cannot equal negative 5 and p cannot equal negative 3. So my domain is all real numbers except negative 5 and negative 3. All right. These last two, I'm just being asked to simplify. You could come up with where they're undefined, but I think you understand that enough now, so we're just going to simplify it. So, number 5, in order to simplify, I need to factor everything I can out. Well, these don't look like the normal trinomials, or the trinomials we're used to factoring with our multiply-add chart like these did. So you have to remember the very first step in factoring is taking out anything that that all of your terms have in common. So I have two terms in this numerator, a to the fourth b and negative 2a to the fourth. Well, immediately I see they both share an a. And then if I look further, I know they both share 4 a's because there's an a to the fourth in both. So now I'm going to open parentheses to figure out what I have left over. So if I took a4 out of a4b, I'd be left with b. So we're dividing it out. If I divided a4 out of the negative 2a4, I'd be left with a negative 2. So when I factor the top, I have a to the fourth power times b minus 2. On the bottom, I have 2a cubed minus a cubed b. I notice both terms have an a cubed. If I divide a cubed out of 2a cubed, I have 2. And if I divide a cubed out of negative a cubed b, I have minus b. Okay, so the first thing I notice is that I have a's being multiplied on top and bottom. So I can factor those out. Now remember, a to the fourth is really a times itself 4 times, and a cubed, a times itself 3 times. So remember, when we simplify them out, we're left with a single a. Or you can remember your rules of exponents say that you subtract the exponents and keep the answer where it started largest. I'm going to keep the a on top. Then I have b minus 2 and 2 minus b. Now, here's something kind of weird, and it has to do with negative 1. So if you look at what we have left over, we have b minus 2. So it's a positive b and a negative 2. But then underneath that, I have a positive 2 and a negative b. So I have the exact same binomial. It just has different signs. Well, if I factored a negative 1 out of one of them, so 2 divided by negative 1 is negative 2, and negative b divided by negative 1 is a positive b. If I took a negative 1 out, now I have a positive b and a minus 2, a positive b and a minus 2. Even though they're written in a different order, it's the exact same situation. So I can say that those have canceled out. And what I have left is an a divided by negative 1, which is negative a. It might be helpful for you to see this written in the other order. So this is really b minus 2 over negative 2 plus b can be rewritten as b minus 2. That's why I said that they're really the same, just in a different order. So I have negative a as my simplified expression. All right, number 6. Again, we are just being asked to simplify. So if I look, x4y minus 3x4, I notice both terms have an x4. I'm left with y minus 3. On the bottom, I notice both terms have an x cubed. I'm left with 3 minus y. So this is very similar to the one we just did. Your x's cancel out, but you're left with a 1 on top because the 4 started out bigger, and when you subtract, you have 1 left over. Y minus 3, 3 minus y. So again, if I take out a negative 1, that would be negative 3 plus y. And if I rearrange it, then I really have x times y minus 3 over negative 1 times. If I write the y first, it's a positive, and the 3 is negative. So those are the same, so they cancel out. X divided by negative 1 is negative x, or negative 1x. And that's it.